Okay. All right. All right. We'd like to welcome our next speaker, Daniel Almeida from Collabora, about Tyr, a new Rust GPU driver.
So, hey, can you guys hear me? Is this okay? So I'll be presenting about Tyr, this new GPU Rust driver that we're writing for the Linux kernel. It implements the same UAPI as Panthor, so at least in my mind, the idea would be to slowly move development from Panthor to Tyr in the following years, right? So during this talk, again, I'll briefly mention what Tyr is. We have to talk a little bit about the UAPI, discuss just a little bit about job submission, so we have to talk a little bit about CSF and how it works. And then after that, my plan here is to just say what the plan is for the short-term future, for the longer future, and basically where we at with both our upstream and downstream branches, because we have two branches actually. So again, Tyr is a kernel mode driver for R Mali. Development started in January 2025. I had a few different ideas on how this thing was going to go. I tried having a mix of C and Rust together and playing a little bit with it and seeing whether that was going to work, but that was a little bit of a dead end. So eventually I just wanted to start from scratch with a full Rust driver, just like AGX is a full Rust driver, just like Nova is a full Rust driver. So we have both an upstream and a downstream branch. And the reason why we have a downstream branch is because we're working on a bunch of abstractions, right? Not only us, but like the Nova team as well, the AGX team as well. Yana is here. There's a bunch of NVIDIA engineers working on Nova, people from Red Hat, and we're all working on these abstractions. And we have to make sure that these abstractions work before we try to upstream them. And one way of doing that is having a downstream driver. So, but we also don't want to be away from upstream, because otherwise we don't exist for real. So this is why we have both an upstream and a downstream driver, or branches, I'm sorry. And for the time being, we have around 4 people working on it. So it's me, there's one lady from ARM called Beata, Alice Real from Google, and there's another person from Google also joining the team. So for now, a total of 4 people. So just roughly, there's a few ioctls that I did not include because I don't think they matter that much, and space is at a premium here. But this is the UAPI that we offer from user space. So the top 2 rows are about memory allocation, memory management, isolation between different VMs, which are like virtual memory areas. It's a way to isolate different apps using the GPU. Then creating an execution context and submitting work to it. That's what group create, group submit, group destroy do. And then managing, as the previous person said, this is a tile renderer, so we have to manage the tiler memory pool at runtime. So it's a pretty simple UAPI, that's my point here. However, Mali GPUs, like most modern GPUs, they use firmware-assisted scheduling, meaning that we have a microcontroller unit that's running at all times once we boot and probe the driver. And most of what we do inside of the driver is actually communicating with this microcontroller. So you have to allocate memory, parse the firmware, boot it, and then through a shared memory region, we're going to be talking to this device in order to submit jobs. Job submission in ARM CSF architecture, basically you submit command buffers to a VKQ, you do a submit, then a VKQ will be backed by something that ARM calls a CSF group. The CSF group has to be bound to a given number of hardware slots. We have a fixed number of them. I think in most GPUs we have 8 CSGs, which are like hardware slots where you can actually submit work to. These hardware slots, they expose sub-queues, which they call command streams. So again, we have a fixed number of sub-queues within our groups. And then inside these sub-queues, you have the actual ring buffer, where you can actually submit jobs. And then eventually the firmware scheduler takes over, dispatches these jobs to the hardware units. When the GPU is done, it interrupts the CPU so that the CPU can complete the fences for the job. So that's the basic overview of how job submission works. So where are we at the moment? When I got started on this project 1 year ago, we had basically nothing, but turns out that nowadays we have quite a lot of things. So we merged support for clocks and regulators. We need that in Rust in order to, power the GPU. We have I/O memory support, meaning platform I/O remap or something, so that we can read and write registers. We have support for interrupts, which was merged in the last cycle. We have support for delayed work items in Rust as well. So far so good, but we have upstream, we have a lot of things that are simply not there yet and they're blocking us. So this is where I plan to focus all my effort next year. So as I said in the previous slides, most of our job is talking to this microcontroller unit. And this microcontroller unit, as I said, we need to parse the firmware and then load the firmware at a given different virtual addresses. And in order to do that, we need a few things. So the very first thing is we need to be able to allocate GPU memory. And so far, this is not possible upstream. And it's not possible upstream because there is no support for gem SHMEM objects. It's something that Red Hat is working on at the moment. Liud Paul is actually the one pushing the patches, but we don't have that yet. We don't have any GPU VM support. We had a presentation about GPU VM earlier today, I think. There's nothing about GPU VM in Rust upstream. Without GPU VM, we can't really boot the microcontroller because, again, we don't have the ability, at least in the way that we'd like, to associate physical GPU memory with the given range of IOVAs, which we need in order to boot the firmware. Also, there's nothing about synchronization upstream at the moment, and so no fences, no sync objects, and also what we're going to do with the GPU scheduler is a big question mark. More on that later, but basically the scheduler, we have, again, the firmware is the one actually doing the scheduling for us, right? So the scheduler in DRAM was meant to schedule jobs as well, so people have been talking about replacing this whole thing with a new Rust solution called the job queue. This is something that Red Hat is working on. So for now, it's a big question mark. On our downstream branch, however, things are much, much better because we're just pulling dependencies from Asahi and basically if things do not work, we just patch them up. Again, this is just for experimentation, so we can do it. It's not upstream. So in our downstream branch, we can boot the microcontroller. We can do synchronous VM binds. We can create groups and then submit jobs to these groups and then wait until the jobs are completed. So this is pretty good. This means that we can submit some work to the GPU and then, we know that basically the work that we're submitting is we submit a move instruction that just moves a constant at a known GPU address, and then we check in user space whether the address really contains the constant we're looking for, and that's working. On our upstream branch, however, as I said, we cannot boot the MCU, so we can basically probe, and that's it. And that was merged. That's being merged for 6.18. And so far, this only works on the RK3588, by the way. We have an IGT branch with a bunch of tests where we test that, allocating memory works, that creating VM works. Again, as I said, that we can submit work to the GPU. I've submitted a patch to upstream IGT, and they'll probably merge it, in the few coming weeks, I suppose. And really, I promised a few people, and I will deliver on this, that I will be drawing a triangle by plumbers this year. So this gives me 2 months, basically, to work on a few things. So the first thing that's missing is the tiler code. I just sat down some 2-3 days ago, wrote most of it, so that's only 500 lines of code, it's not much. And the other thing that's missing is when you submit jobs to Panthor or Tier, you're submitting a batch, right? So it's not one job, it's a collection of jobs. So there can be one job inside the batch can depend on another job inside the batch. And for reasons of I did not have time enough to write that code, it doesn't work. But again, it's just a matter of sitting down and writing some more code. There's no blockers. I guess in 1 or 2 weeks I can weed out the bugs, and that's going to be it. And that's it. After that, basically everything else is already in place. As I said, we can basically submit a simple job, need to fix these two things, and then we're going to be able to basically start rendering. Hooray. Next steps for downstream, as I said, draw a triangle, investigate CTS, probably get some CTS tests to pass, probably compute. We should probably be implementing your own software scheduler at some point because we have a fixed number of slots in hardware where we can execute work. I think for most Mali GPUs it's 8 or 16 or something like this. So what happens is if you have more than 8 or 16 different programs trying to use the GPU at the same time, you have to schedule that somehow, or evict somebody or something like that, or implement some fairness policy because otherwise this doesn't work, right? But yeah, after that, we just plan on deploying that on actual devices for testing. I'm talking to one company out there. I don't really want to name them at the moment, but we're targeting real devices as soon as we can put out something that can draw a triangle or that can run VK-cube or whatever. Then we'll be investigating some devices to be testing tier on, at least the downstream branch, right? For upstream, again, I really, really need GPU VM and shared memory to work. This is something that the people from Red Hat are working on. I suppose they're going to come out with something for the next couple of cycles in the kernel. But for now, in upstream, we're blocked. Because, again, without these two things, we cannot boot the MCU. The MCU is basically everything in the GPU driver, so we're basically stuck there. And once we do that, then we can probably, start supporting more things like BO creation, etc., VM binds, etc. For downstream, the more long-term plans, so in 12 or 18 months or something, probably power management, because if you plan to use this driver on a mobile device and there's no power management, that's of course not going to work. Again, we need a scheduler. We need to implement some reset logic because at the moment, if the GPU crashes, then the whole system goes down, and that's not ideal for obvious reasons of people wanting to kill me as the developer for this. So async VM binds, which is something that I didn't have the time to work on, more IGT tests, improve the CTS results. Hopefully this and Panthor will be comparable, and then add support for more things, more Mali GPUs. For upstream, basically the same thing, but we also need to figure out what the scheduler is going to look like. Whether we're going to go with this new Rust scheduler that doesn't really schedule anything, basically tracks job dependencies, only called the job queue or job manager or whatever, or whether we're going to be using the old Durem scheduler binding code that Azahi Lina wrote. I only see these two ways. And then again, it's the same thing: power management, reset logic, CTS, etc., etc. So very briefly, that's the state of the driver. If anybody has any questions, feel free to ask.
I'm not too familiar with the actual hardware, but do you even need a scheduler if you move to something like user queues where user space would be interacting directly with the firmware without even needing to go through the kernel driver?
Please don't say the words user queues. I don't really want to get in this discussion. This is going to be a major thing. But eventually, of course, everybody wants to support that. but we don't want to support that from the get-go because, again, it's not really clear how this is going to work at the moment, even for the established C drivers like Panthor. So yes, in the future, probably not, but at the moment, we're not doing user mode queues at all.
Okay.
So that's exactly my question was. You probably don't have to go through the DRM scheduler if you have a user mode queue. So weigh your options.
Yeah.
And so can you clarify a bit, because I think your predecessor said that Panthor is actually intended to be the default driver for all upcoming Mali GPUs. So where does Tire fit in that image? So is it a complete alternative to Panthor, or sorry if I didn't understand correctly in the beginning?
The thing is, until Tier is actually working in production and as beefy as Panthor, you know, as reliable as Panthor, then yeah, we cannot say that Tier will substitute Panthor because we're really not there yet at the moment. But the future plan, hopefully in a few years, again, we're talking about years and years down the line when this thing is, has more features, is more stable, etc., etc. I hope that people will consider migrating the development to Rust and to Tier.
Okay, thanks. And a brief comment on the scheduling topic. I guess we have, I've got a few news about that, but I suppose we talk about it on the schedule workshop, because there are some very, very new proposed solutions for your problem from like last week, fresh from the oven, so to speak. So there's definitely a lot to discuss. That's going to be quite interesting.
Yeah, yeah.
One quick response on the scheduler thing. Part of the problem is that the CSF only has 8 slots. So if you want to have more than 8 applications running on your laptop, you can't do user space submit to firmware. There are other hardwares where you have more like 4096, and then suddenly it's fine, but like you have it.
The new firmware scheduling removes that limit. So you can have as many as you want.
Oh, that's great. Good to know.
Fixed with new firmware is a good option. But yeah, with the current stuff, 8 is not enough to be able to do anything. But if you're fixing it, then we're good. I was just also going to ask, how do you feel like things are going and progressing in terms of upstreaming these components? Because the downstream looks awesome. The upstream situation looks significantly less awesome based on the PowerPoint slides. So do you feel like things are making good progress there, or are they getting blocked on things? Like, what does the future actually look like in the next 6 to 12 months?
I really think that, as I said, I said to Danilo, and he talked about it during FOSDEM this year, where I told him on a quote that 2025 would be the year of Rust GPUs in the kernel. That got postponed to 2026, apparently. But I'm pretty happy, especially because of Danilo as well, Danilo Krumish from Red Hat. I feel like he's been doing an awesome job at steering the team and, getting everything on track. And although, again, as I told you during the presentation, I really want to get GPU VM, SHMEM objects, etc., etc., the fact that they're not available today do not worry me very much because I see a process. I see things coming together. I see that, okay, they're not here today, but maybe in 1 month, in 2 months, in 3 months, they're going to be there. So I'm not too worried. I'm actually pretty happy. More questions?
I guess, as someone who doesn't know much about Rust, how much is similarity or compatibility with Panthor either at the UAPI level or just in how the code vaguely looks? Is that a goal, or is it an explicit non-goal? How's that turned out, basically? Have you rewritten stuff and found that it works way better in Rust? I don't know. Any interesting thoughts about it?
The UAPI is 100% the same. So we have to have the same UAPI because we want to achieve drop-in compatibility with PanVK. But internally at the driver, although a lot of it is based on what we currently have for Panthor, We are doing a few things differently, by things like the interaction with the shared memory region, again, because I feel like this is one of the major vectors of, because you're just addressing different regions of memory. This is something that Rust can help with. Locking, we have a different way of dealing with locking in Rust. So I don't have a specific goal of just doing things differently just for the sake of it. But if at some point we see that, hey, we can do this different on tier, like the scheduling thing that we're discussing, then perhaps. But the UAPI has to be the same.
Cool, thanks.
All right. Thanks a lot, Daniel. We were at time. Thank you.